As we move on to using the Hitachi display and our full color LCD touchscreen display, we'll need a quick crash course on arrays and string variables. Arrays are simply a variable with many parts. For example, this is an array. The variable name is my map, and there are 8 parts in the array called elements. I loaded up the array with 8 different elements within the curly braces, all separated by commas. Once I declare the array, I can write or read any one of the elements. Now the elements are simply numbered in sequence, but the first element is element 0. That's very important, as you'll see in a second. So to read the very first element, we'll load it into another variable like this. The screen coords variable now equals -33 because it accessed the first element in the array, element 0. Arrays are 0 indexed because if you can picture what the compiler is doing in the background, when you declare the array, it designates a sequence of RAM memory locations in which to store the array. That memory location could be anywhere. It'll grab the first available block of memory that's big enough to hold the array, and it'll store that address for the variable. Now, when it accesses that block of RAM, the index number is actually an offset. The compiler gets the address of the first memory location and then accesses the different memory locations in the array by adding an offset to the first address. So to access the first memory slot in the group, we'll offset the RAM memory address by 0, no offset. To access the second memory slot, we'll add an offset of 1 to the base address. To access the third memory slot, we'll add an offset of 2, etc. If we were to read the fifth element, we would add an offset of 4, like this. And screen coords would now equal -16, because that is the number stored in the fifth element in the array. I could also write to any element at any time using the array variable name and an index number. This stores the number 24 into the third slot in the array. The third slot has an index of 2. Now, when declaring an array, the compiler needs to know how much memory to set aside. There are several ways to do this, all of which are valid. In the first example, I did not designate the number of memory locations it'll need. So it assumes that the values in the curly braces are all of the elements it'll need to store. So it counts up how many elements there are and sets aside that many memory locations. In the second example, we set the array size, but like declaring any other variable, you don't necessarily have to provide numbers to be put into memory. But you do have to tell it the size, what size to make the array. You can't leave the array size empty and not include any element values because it doesn't know what size it needs to make the array. You need to provide one or the other at a minimum because it needs to find a large enough memory block in which to store the array. In similar fashion, in the third example, you can see I designated 18 memory locations, but only provided values for the first 4 elements. Now that's okay too. We told it how many memory locations to set aside, and it'll just assume we'll fill in the other elements later on. One last very important thing before we move on. It is very important that you not attempt to index outside of the array. For example, if we declare this array, it sets out the array in memory, 1, 2, 3, 4, 5, but now I attempt to read my map 5. Whoops, I just made the common mistake of simply forgetting that the index starts at 0 when I attempted to read the last memory location in the array. I am now reading outside of the array because I'm attempting to read the 6th element in a 5-element array. So if you'll recall how the computer works, how the compiler works, when I declared the array, it set aside some RAM memory for the array. Now I have no idea where that block of memory location is. Neither do you, and neither does the compiler until it compiles it. It simply finds some available memory that's big enough to hold the array and designates it. So now, When I ask it to read my map 5, it adds an offset of 5 and simply goes and reads that memory location. You have no idea what that memory location is, but you're about to find out what's there because it will read and make my number that value now. It will be completely random. Even worse is if I attempt to write outside of the array. Again, you have no idea where on the Arduino that array is stored. So when you forget that the array is 0 indexed and you attempt to write outside of the array, you have now just written a value to a completely random memory location on the Arduino. It might be a harmless register, it might be a critical register, like one of the lines in your program. Your program is stored in memory, right? So you just nuked your own program from within because you just randomly wrote randomness in the middle of your program. Now, this is especially true if you write way outside of your array because, again, the index is just an offset. So if I have an array the size of 5, but attempt to write to that array with an index of like 323, then it's writing numbers to who on earth knows where on the Arduino. You could be setting all kinds of weird registers like clock speed registers. Who knows? Okay, now that we have a handle on arrays, let's get into what are called string variables. We've actually been using them already, but didn't really explain them or focus on them. A computer only understands numbers, right? But we communicate using both numbers and letters, or perhaps Egyptian hieroglyphics, if you're into that sort of thing. Regardless, we communicate using a lot more than just 10 numbers. If you're communicating in, say, Cantonese, you're using something like 37 different strokes and upwards around 200 radicals. So computers just simply do not and cannot understand us. This will become more significant when we get into artificial intelligence in course 5, because a computer only deals with numbers. That's it. That's all. So how on earth does a computer perform artificial intelligence functions that can be downright frightening in their power, like speech-to-text recognition, looking for keywords in your conversations and passing that info along to the NSA so you can get put on the terrorist watch list, all without the computer ever even understanding human language? It's not paranoia if they really are watching you. So how does artificial intelligence do this? That is a mystery for another day. The emphasis right now is that our computers do not communicate with letters. A string variable is just a variable that contains characters. For example, we've been using strings all along when we sent a print command to the serial monitor. Serial print, this is a string variable. The string variable is those letters making up that sentence. In fact, it is technically an array. It is an array of characters with each character between the quotes being one element in the array. Now, the computer doesn't know their characters. In fact, it converts them into numbers so it can manage them. What kind of numbers does it convert them to? Well, ASCII, of course. See, remember our fancy schmancy ASCII chart? In order to send a string of characters to our Hitachi display, we would convert the individual letters into ASCII codes, which was a number, send that number to the display, and the display would interpret what to do with the ASCII code and how to display what we wanted on the screen. In the case of the Arduino IDE, some nice person has already encoded the entire ASCII chart into the IDE. Look at all the work they saved you. Now to send text to our Hitachi screen, we just type it out in quotes. The Arduino program converts it to ASCII, sends it to the Hitachi screen, and voila. It'll appear just as we typed it. Is that slick or what? So string variables usually need to be declared just like any other variable. And just like any other variable, you don't have to load it with a value when you declare it, but you can load it up if you so choose. So it goes like this. So I have to first tell the compiler what kind of variable this is. It's a character type, so char indicates that it is characters. Then the name of the variable, and then give the variable a value. Now, just to confuse the matters, there is a string object. It has a capital S which is very similar and does a lot of the same things a character array does, but it does it at the expense of more memory. We won't be using that because the first thing you need to realize is that character arrays consume a horde of memory already, and the string object takes even more. From here on in, every time I refer to a string array, I'm referring to a character array. Now, it is an array. Each of those characters in the array consumes a memory location, and there is a hidden character at the end called a null character that indicates the end of the string. So each of those characters, including the spaces in between the words, each consume a memory location. So this simple short statement has 46 characters and spaces and a hidden null character. So it consumes 47 bytes of memory. Doesn't sound like much, but considering you only have 2,000 bytes of memory to begin with, that one little string just consumed almost 2.5% of your entire available RAM. So let's say you're using your Hitachi display for interaction with the user. If a simple and short message consumes an average of 40 bytes of memory, 50 canned text messages in your sketch would consume all of the available RAM on the Arduino Uno. No room for any other variables, no room for printing to the serial monitor because that uses string variables, etc. In fact, if you take a look at an example code in Arduino, go to File, Examples, SD, and Card Info. This is a sketch that simply checks out an SD memory card plugged into the Arduino through an SD card reader shield. Now take a quick look at the sketch. There's not a whole lot there, is there? But look at all the string variables. This very short little sketch consumes a whopping 1,348 bytes, more than half of the total RAM available. Because character arrays are arrays, you can both read and write specific elements within the array, exactly like you would write to any other array. It's just that you need to bear in mind you are dealing with a string variable. One oddity with the C programming language, which Arduino is based on, is that if you have a single character, you have to put it in single quotations. If you have multiple characters, you have to put it inside double quotes. So if we store a character into the mySentence variable, like this, it would change the lowercase s in the word sum into an uppercase s. That's slot 8. Notice because I'm only dealing with the single character, I have it in single quotations. Weird. I know. Don't look at me. I didn't make the rules. Honestly, I have no idea why they did it this way. As with so many areas in these courses, I am simply introducing you to these concepts so you can use them. There is so much to manipulating strings. I could do several lessons just on that. But you can pursue this in more detail if you're interested. I won't go into detail because we don't need it for what we're going to do in these courses.